Utility fail screen capture. This screen capture of an actual live demonstration is designed to explain in detail the way the IEM Power Systems Rotoblock UPS works. It shows how, even when utility power fails, the integrated Rotoblock UPS system maintains clean, uninterrupted power to the facility's critical loads. Normal operation. At the opening of the screen capture, the system is running in normal operation. Note that breaker DM is closed, utility power is present and supplies the critical load. The generator is enabled but not operating. Breaker DG is open. The Rotoblock is fully charged at 3000 RPM and has 10.2 seconds of available discharge based on the current critical load. It is ready to act as a UPS. At all times, power flows to the critical load through the UPS choke, and so the Rotoblock conditions all power supplied to it. For the purpose of this demonstration, all loads are regarded as critical, and so essential loads are zero throughout. Utility power is lost. At this point, utility power fails, but breaker DM remains closed to allow the return of utility power if it is a short power cut. Breaker D1 opens, isolating the system from the utility. If the utility returns, the UPS will synchronize across D1. The UPS now provides all power to the critical load. Note that the RPM of the accumulators drops as energy is transferred to the alternator to supply the critical load. The discharge time starts to count down. The diesel generator has not yet started, and with breaker DG open, it remains disconnected from the system. 1 second after loss of utility. The diesel begins startup if utility power remains unavailable. The RUPS continues to power the critical load, and its discharge time has now dropped to 7.9 seconds. A start signal is sent to the diesel engine generator. 3 seconds after loss of utility. The diesel genset has started and is producing voltage. Breaker DG remains open, and all power to critical loads is still being supplied by the Rotoblock. The utility breaker DM remains closed to allow utility power to return. 5 seconds after loss of utility power. The UPS continues to provide all power to critical loads. Breaker DM is opened, isolating the system from the failed utility. Simultaneously, the ATS closes the generator breaker, DG. Now the generator is ready and breaker DG closed. Synchronization occurs across breaker D1. 7 seconds after loss of utility power. The generator is synchronized with the UPS and critical load. Breaker D1 is closed, allowing the generator to gradually contribute power to support the critical load. In the seconds that follow, note the soft handover of the load to the diesel genset. The Rotoblock supplies about 1200 kilowatts of power to the critical loads, with the genset now contributing over 400 kilowatts. 8 seconds after loss of utility power. The generator is accepting more load. The generator continues to support the critical load with nearly 750 kilowatts. The Rotoblock is still contributing about 1000 kilowatts of power to the critical load. The Rotoblock is almost fully discharged at 1970 RPM. At 1800 RPM, it will reach parity with the alternator and stop discharging. 8.5 seconds after utility power was lost. The diesel genset continues to accept load and has replaced the UPS as the primary provider of power to the critical load, supplying nearly 970 kilowatts. The RUPS alternator provides the balance to the critical load. 9.5 seconds after utility power was lost. The diesel genset now provides all power to the critical load. The Rotoblock was almost completely discharged at 1900 RPM when the diesel genset had accepted the full critical load. Rotoblock recharge begins. The critical load remains fully supported by the diesel engine genset. The Rotoblock is recharged using surplus genset power. The accumulators will be fully charged after approximately 8 minutes. The RUPS continues to condition the power to the critical load. About 8 minutes since all load transferred to diesel. the rotoblock is fully charged at 3000 RPM and ready to act as a UPS. Discharge time is 9.6 seconds based on the 1600 kilowatts of critical load. The genset continues to feed conditioned power to the critical load. Utility power returns. Utility power has returned and voltage and frequency are normal. Utility breaker DM remains open, and once a stable utility is established over a timed period, the diesel generator synchronizes to the utility. The diesel genset still provides conditioned power to the critical load via the UPS choke. Normal operation resumes. The utility is stable and is allowed to take the load now the system has resynchronized to it. Breaker DM closes, and the critical load is supplied with conditioned utility power via the UPS choke. Simultaneously, the genset is disconnected by opening breaker DG. The diesel engine is allowed to continue to run with no load in cooldown mode. Note that if the utility was regarded as unstable, the system could have been held on a diesel genset supply until the operator elected to return to utility supply. The system is now running in normal mode, and, because of the rotoblock UPS, power to the critical load was not compromised at any stage.